I'm Kirk Harnack. On This Week in Radio Tech, I'm joined by Chris Tobin and two guests, David Bialik and Mike Dosh. We're talking about informative sessions at the upcoming AES convention in New York, and we'll get some insights into AoIP development for broadcasters. TWiRT is up next.
Netcasts you love.
From people you trust.
This is TWiRT.
Bandwidth for This Week in Radio Tech is brought to you by CacheFly at CACHEFLY.com.
This is This Week in Radio Tech, episode 94, recorded August 10th, 2011. AES and AoIP. This Week in Radio Tech is brought to you by Axia Audio and the new Radius IP audio console. Feature-rich, affordable IP audio consoles from Axia. On the web at axiaaudio.com. It's time for This Week in Radio Tech. Hi there, I'm Kirk Harnack. I'm really glad that you have joined us. This is the show where several propeller head geeks, me and Chris Tobin, sometimes Chris Tarr and Tom Ray, will get together and talk about radio technology, and we're able to bring in some guests from time to time. And that, hey, today, on this show, we've got two, not one, but two guests for you. I'm very excited about bringing both of them in here. Let's see. First of all, let's make the quick round robin. I'm Kirk Harnack, and my full-time job is I work for the folks at the Telos Alliance, Telos, Omnia, and Axia, and I do some technology there and some sales and kind of oversee making sure products get out the door and in the hands of people that want them. And I have another full-time part. I have another job that used to be full-time, not anymore, and that is I have some radio stations. Me and a fellow named Larry Fuss are partners in some broadcast stations. So we have two in Mississippi, and we're leasing a couple more, and we have two in American Samoa. So that's kind of interesting. I do occasionally get my hands dirty in the transmitter and building studios and just kind of keeping things on the air. I've been dealing with stream issues in the last couple of weeks, for example. So that's me. Let's take it out to New York City and talk to the best-dressed engineer in radio. It's Chris Tobin. Hey, Chris.
Hello, Kirk. I'm with the CBS radio group here in New York City, and we have 3 AM stations, 3 FMs. I'm the broadcast technologist, and my job is to find technologies that help us to make money and produce programming that nobody else can top, and that's what we do. And so far, it's been pretty good this summer.
Well, Chris, we're glad to have you with us, and you often can speak to technology. You have sometimes the opportunity to check out technology that's either on the cutting edge or even technology that's really intended for another industry, like maybe television, and apply that to radio. So when we're going to bring our guest in right now, and that's David Bialik. And Chris, I bet you that you and David have some things to discuss about new technologies, because that's part of what David is here to discuss. David, welcome on in. We have David Bialik, also in the New York area. David, where are you? Are you in New York on the island, or are you
I'm just outside the city in Rockland County.
Good deal. And tell me, give me a couple sentences about David Bialik, and then tell me about that microphone.
Well, I'm an independent consultant here in the tri-state area, and I service both broadcasters, streamers, and people not in the broadcast industry on technology. And that's basically what I've been doing for the last 25 years. Before that, I was chief engineer of a couple radio stations in New York, and I've known Chris for many years. And this microphone was given to me by a good friend, Cliff Rogers, along with Hans Dietze, at the 127th AES convention back in 2009. This microphone was only used at the 1964 World's Fair and also at that AES convention in 2009. The interesting thing is when RCA prepared all the broadcast booths at the 64 World's Fair, they basically loaned all the stations the equipment. So this one was loaned to WNYC, and afterwards it was given back to RCA. And it seems when RCA was going down, Cliff's supervisor handed it to Cliff, and in 2009, the AES, basically myself, decided that we should have a tribute to the technologies that the RCA Corporation brought to the audio industry. And it was really sad when GE took over RCA. They tried to basically erase most of the RCA history, since they were mainly interested in the NBC part of the company. So Cliff and Hans handed this to me and said, "Thank you. This is the first time anyone's ever recognized that RCA added to the industry." So I love this microphone, and it's in mint condition, and it's the only microphone that makes my voice sound great. So I call it the Great Liar. So.
It does sound nice. It's particularly clear. We've had some people in the chat room asking, "My God, how big is that microphone?" Well, it's just close to the camera. So objects close to the camera are larger than they are, smaller than they appear. Tell me, what is the size of that? People are saying, "Hey, is that thing 20 pounds? What's the deal?"
Well, the thing is heavy, and the stand with it is a weapon. It's around 7 inches or 8 inches high and around 3 inches wide. And it's just a beautiful microphone. And you can tell Leo Laporte, I have the coolest microphone that ever appeared on the TWiRT network.
It is pretty cool. In fact, now that's an RCA
DX77.
DX77. I thought it was, but I may have gotten the letters wrong. DX77. That's actually the very first mic that I used as a broadcaster at a public radio station, WEKU FM, in Richmond, Kentucky. And they had the RCA, what console was that? About 10 faders, rotary knobs. Chris Tobin, don't be shy here. You chime in if you know what this console is.
Was that a BC10? BC10, yeah.
It's a BC10. There you go.
BC10.
The big brown
BC10.
beast.
Yeah. Okay. No, ours was blue. Blue with a silver front panel.
I worked on one of those.
They had a couple of versions of that coloring. You had the military gray ones, and then they had the blue, which was, I think, at one point a series of colors for late 60s. I forget when they changed a couple of colors on that.
Yeah, I think we had one of those at WAMU FM years ago when I was there.
So that microphone now, that is a ribbon microphone. That's the technology inside. Can you tell us anything about how that works, and does the ribbon wear out?
I cannot tell it as well as Chris Tobin can, because Chris can do a much better job to this. Go ahead, Chris.
All right. Well,
I'll put you on the
with
spot.
Microphones of. No, yeah, it seems to be my forte these days. In keeping with the tradition of something topping something else, I have here what's known as a Baby 44. This is a Type 44 RCA ribbon microphone. You may be familiar with it. You've seen it probably on many television shows from the 50s and 30s and 40s that would hang from a large boom. And this, too, is a ribbon microphone. And basically, if you can envision we'll go with simple images. A horseshoe-shaped magnet, and in the center, between the poles, between the edges of the magnet, is a ribbon, piece of aluminum, that's folded in an accordion style and is suspended between the magnet. As you talk into the microphone and your voice, your sound goes across the aluminum, it actually vibrates to your audio, to your voice, and creates a current, which creates the audio that you hear coming out of the microphone preamp. Ribbon mics have been known for a very warm sound, very, very open, very broad sound. That's what I'm using now. That's what David has. You can destroy it by simply puffing, popping your P's too much. They're not meant to be close microphone, like talking up real close like this is not good. And then they're meant to be talked to from a distance. So that's in the simplest terms. It's a ribbon mic. It truly is a ribbon of aluminum, very, very thin. And when I say aluminum foil from your kitchen, it's not that thick. It's maybe the thickness of a hair follicle. It's very, very thin. And if I was to open this up and show you, you'd see it moves with any little brush of air.
Yeah, and if you open it up, it's very hard to put back together.
There's some experience. That's true. Oh, man. Well, hey, as fun as the microphone is, and that is a beautiful mic, and I have good memories of that mic as well. Although, unfortunately, the one that I used, doodling disc jockeys had taken a pen, and doodled on the cloth that's right behind the punched metal outside. So there's some white cloth in there. Yeah, so they had doodled on it and put it, filled it up with some Bic ink. Oh well, it was not in great shape, but they are known for having some nice detail, and they certainly do. But that's not why we're here to talk about microphones, although that's fun. David, you're going to give us a little bit of a preview and an invitation to the AES convention. It's coming up
Correct.
in New York City. Talk to us about that. What's your function there?
Okay, for the past, I guess, 25 years, I've been chairman of broadcast sessions, and a few years ago, we changed it to broadcast and streaming sessions. And basically, what I do is I organize all the sessions for broadcast and streaming from the beginning of the convention till the end, and I fight to have things done my way, and it's been very successful. One thing that the broadcast and streaming sessions does is, other than like NAB or some of the other shows, we're definitely not a sales presentation. We're discussions of technology and technique. And we very much discourage any talk of sales in the tech sessions. That's for the exhibit floor. And we do have a large exhibit floor as well. And this year we're putting together around, if things go well, around 18 or 19 sessions throughout the convention. The convention starts on October 20th, which is a Thursday, and it goes through that Sunday. And we have some really esteemed names, some from your company, Kirk, and we even have Kirk Harnack and Chris Tobin on some sessions. But we have a lot of sessions I'd like to talk about. The first, I'd like to divide the sessions up into my own system where we talk about your content inception, production, transmission, and reception. And that's how I try to take at least some aspect of each of those categories and create a session on. So one thing that we're doing is I have John Storick, who is a very well-known acoustician, architect, putting together a session on facility design, renovation, and retrofitting. One of the big things now on when you're doing a project is the owner doesn't want to build a new facility right away. He wants to take what's there and use it to its best of the ability. So John's going to do a session on how to make the acoustics sound right, and how to retrofit it for modern technology, because a lot of studios now were designed for analog, and we're in a digital world now. So that's one session. And I'm going to jump all over the place just because my notes are very disorganized, and I hope you don't mind. And if you have any questions,
I want to mention to
me.
folks, if you want to follow along at home, go to the website aes.org, and there's a link there you can click for this convention in New York,
which is the 131st.
Man.
It's the 131st convention, and very soon now we're going to have all the descriptions up there. But the next session I'm going to talk about is listener fatigue and retention. The worst title for a session ever, but the greatest topic. And
I guess you're hoping not to fatigue the listeners who are there. That's not the idea of the session.
Well, that is exactly the idea, because around 4 or 5 years ago, Marvin Caesar, who was then head of AFEX, came up to me and said, "Hey, David, there's never been a session on listener fatigue." And I said, "Gee, that's a great topic." And I researched for almost a year and found out that no one has made official studies of it, and only one company had, and they weren't releasing their results. So I put the session together, and this year I have David Wilson moderating it from the Consumer Electronics Association. And we have on that panel Ellen Sheffield from Towson University, who is also the person that NPR and Ubiquity go to for all their listener fatigue questions. We have Sean Olive of Harman, Greg Monty of Citadel, I'm sorry. Frank Foti, a guy I'm sure you know. And Greg Oganowski is going to be on that panel. Thomas Lund's on that panel from TC Electronics. And Todd Baker from SRS Labs. And there might be some more people yet to join that panel. And it's a really important thing because some people will tell you, oh, it's the processing and so forth. The one thing that's common throughout the years, the first and major thing that is important on listener fatigue and retention, content is king. And because I don't know if you remember when you were little, but I sure do, rushing home to listen on scratchy AM radios, the CBS Mystery Theater.
Oh,
and
yeah.
Absolutely. Sure enough, my reception was awful, but you would listen for the content. And if you can make your listeners intrigued by the content, now all you have to do is make them comfortable. And that's one of the things that we're going to discuss. So that's right there is one session we're going to talk about. Then, flipping over to the 21st century, we're gonna have Bill Sachs, who you all know, with some others, talking about improving the streaming audience experience. There's a lot of talk and a lot of different players out there and everything. A lot of people are caring about how the quality of the audio they're putting into the computers, but they're not caring about how it comes out. And no one remembers that it's coming out of probably 3-inch speakers that they bought at Staples. And sure, it might have a brand name on it, but there's no quality there. And we have to remember that and try to aim the audience experience the best way possible on the worst possible equipment. And that's going to be an amazing session. Bill Sachs has been working real hard on it. And then, staying in that realm, I have Valerie Tyler putting together a session called Streaming with HTML5. HTML5 is the talk of the internet world right now because not only is it the latest hypertext markup language, it will have the media player built into the browser. This is what people are realizing is this is the first attempt at a media player standard. So that's going to be really interesting. The Apple people have been pushing for HTML5, as everyone who's been following the Apple Adobe fights and so forth. So I think that's going to be a real exciting session, and we're going to learn a lot. Then I have another session called 21st Century Backhaul and Remotes. This session was originally designed by myself and Tom Ray. Tom had to back out of doing it, but we have this guy, Chris Tobin, that's going to be on the panel, along with Kirk Harnack and some others. I'm sure you guys know those guys. And we're going to talk about all the different ways of getting your program material back to the studio that it can be transmitted out. It's not just balanced lines anymore. I mean, Chris, when was the last time you were able to get a 15 kC circuit?
Oh, well, yeah, we don't do that anymore.
Yeah,
the phone company, yeah, it's very scary.
Yeah, so we're going to talk about all the different ways, and Chris is on this panel, and so is Kirk, and we're going to talk about everything from doing POTS lines and ISDN, internet, and some other ways that Chris has come up with. And we also have on this panel someone that probably does more remotes than anybody, Bruce Berenson from SiriusXM, and he's going to talk about some of the different ways he's had to solve to get program material back to the studio, and it should be really interesting. Next, we have Eric Small putting together audio engineering supporting people with disabilities. And the nice thing about this is we have the chief engineer of the Mass Media Bureau of the FCC joining on this panel. I'm not going to say her name just because I can't pronounce it, but this session is really important because the FCC is very much close to a standard on this, and people that are blind or deaf are going to be able to get content from broadcast, which is really interesting. And then following that, we have Skip Peasy chairing the session, Television Loudness and Metadata. And we all know about the CALM Act and so forth, so that's what we're going to be discussing. And also dial norm and how to control loudness. And then another television session, we're going to be talking about the lip sync issue. If you've noticed, if you have like a very large television, there's always a synchronization issue and so forth. And John Abrams over at Nutmeg Post with some others is talking about various ways of solving that problem. So that's a great session right there. And excuse me while I turn the page.
I got no problem solving that problem. We just need to show old Japanese movies all the time.
Yeah, but Godzilla dies. And then what are you going to do? I'm going to be chairing a session called Streaming and Encoding. And Kirk, you're going to be on that session too. I don't know if I told you that.
Either me or Frank Foti will be, yeah.
We're going to be talking about how to best encode for internet and doing broadcasts. And it's going to be a very good panel. There's a lot of new technologies out there, including the one that your company brought out, Kirk. And one of the highlights of the convention is something that I'm putting together, and I would like to ask your listeners, viewers, to help me on. We're marking the 50th anniversary of FM stereo broadcast in the United States. We're putting together a event, and it's going to be at nighttime, not during the day of the convention, but at night. And most likely it's going to originate from a theater in New York City. And we're trying to get together a lot of the people that were involved with the development and the introduction of FM stereo. And I am going to ask anyone that is enjoying this podcast or not enjoying this podcast if you have any testimonials from when people when stations turned on their stereo pilot and listeners said, wow, this is great, or I don't know what I'm hearing, I would like some listener reactions from when that happened, or if you have any recordings of when stations turned on their pilots and so forth. We're looking for all of that, and I ask you to email me at broadcast@aes.org. So if you can put that email address up in the show notes, Kirk, I'd appreciate it.
Broadcast@aes.org, and that'll go to you. And that's for folks who have recollections, recordings, or just personal recollections of when their FM station went to stereo, the first time they saw a stereo pilot light. And I guess, back then, a lot of folks didn't have a stereo receiver. So I'm sure there were plenty of stations, chicken and egg problem here, where stations were transmitting in stereo. But
I remember listening much later than 61 because I wasn't born yet. But when my father bought his first stereo and we listened, and I said, wow, the audio surrounding and so forth. I remember that to this day.
Yeah, I suppose a lot of people, some people probably had stereophonic turntables and amplifiers, so they were playing stereo from their hi-fi.
That was around 3 years before that. So stereo was around, and I don't know when it was introduced in Europe, but I know this is the 50th anniversary of it being introduced in the United States. Now, the next session I'm going to talk about is really cool. I don't know if you've heard, there was a radio production put on PRX called The Witches of Lublin. Sue Zizza produced it and did the sound effects. And she's going to be at the show, and she's going to give demonstrations and so forth about how they created the sound effects, because she's a well-known Foley artist. And it's phenomenal, especially when she does her effects, and she shows you how she's doing them in surround, and you're listening in surround. It's amazing. And that session, I can tell you, will be Saturday morning of the convention, and it is worth waking up and going to the Javits Center early just to hear that session. It's phenomenal. The next session, which will really interest most of your viewers, is audio processing for radio. I've got Steve Fluker of Cox Media chairing that session. And we have Bob Orban, Frank Foti, Jim Hogue, and James Johnson on that panel. And I don't know if you know this, but James Johnson, otherwise known as JJ, he and Karl-Heinz Brandenburg were the developers of the MP3. So it'll be a really interesting panel, and they're going to talk about the technology of audio processing and so forth. So it'll be real interesting. Then we have Ray Archie of CBS talking about working with content delivery networks, something I know that you do here in the TWiRT house a lot, because the only way to distribute a stream is to go through a content delivery network. And unfortunately, there's no standards between the different delivery networks out there. And that's the whole gist of the panel that Ray is putting together. Then I have a really great panel, Bice Wilson of Meridian Design, who has built he and John Stork have basically built most of the major broadcast facilities in the last few years. So Bice is going to be talking about designing and building a facility from ground up, and that's going to be great. And I know I'm saying great a lot, but hey, I'm a person that's behind the scenes. I'm not used to being on the microphone. And then we have new initiatives in digital audio playback and automation for radio. Paul McLean is putting together this session with me, and it is going to be talking about basically playback. And what a lot of people don't realize is, if you remember, it was almost a revolution in the 90s when the DigiCart came out. Now everyone is replacing the DigiCart with different digital playback systems. And that's what we're going to be talking about there. And the next thing is media file management, storage, backup, and retrieval of your assets. Because you're producing all these computer files now, and now we have to come up with standards on how to retrieve them, play them, all the asset management and so forth. So that's a big issue, whether you're in radio, television, production. It's a major issue. And then on one of the nights of the convention, we're going to have a major event, which is, I believe it's going to be 2 hours. Henry Cohen and I are putting together a session, it's an event on how to live with and work within the new rules for white space, which is a big deal, especially in New York City, but it's going to be a big issue around the world, around the country, since all the rules have changed. And
David, this thing about white space, this is where consumer devices get to use unused TV channels that are unused in your area?
Yeah, and a lot of people have to still do production, and there's a lot of frequency coordination, and I'm sure Chris can give us some great examples since he's running around Manhattan all the time.
Yeah, the white space topic is pretty sensitive here in town, and we've got probably one of the most highest RF density areas to go on the globe. And the white space, let's see, what was it? It was white space, the new restrictions on wireless frequencies. There's a few things, yeah. It's not easy getting anything done wireless here in town.
Chris, would I be correct in saying that that broadcaster's concern is that the consumer devices that are supposed to automatically detect, hey, there's the spectrum here is not in use from this frequency to that frequency. We're worried that those devices may be wrong in deciding what frequencies to use and will cause harmful interference to some production, some back office thing, or even an on-the-air broadcast.
Absolutely. Matter of fact, even without the devices that are supposed to be self-aware or intelligent radios or software-defined radio systems, I know of a few places here in town in their conference centers where we've turned on wireless receivers and there's just noise on the frequency we thought we'd use, just noise. It's wideband noise coming from somewhere, and we had demoed or played with some equipment that was designed to be self-aware, and it still continued to function because the noise, I guess it couldn't correlate what it was and thought it was just background noise, the channel itself, the frequency. So it said it was clear to use, but it was definitely not usable. So it's kind of scary when that happens. And then if you're using something that is active, it may just step right on you. Go ahead.
I was playing with some self-aware stuff down in the Wall Street area a week or two ago, and it was really amazing that the machine could not find a frequency to work on. So,
right. Matter of fact, around 9/11, it's going to be even tougher to do it wireless.
I'm sure you're going to be working out of Tom's window.
Yes, we'll be working out of Tom's window.
David, have we gotten through all the sessions yet, or is there more?
There's one thing I would like to mention. I would like to mention that the Society of Broadcast Engineers is going to give certification exams at the convention. And one of the things that's great about this is, unlike at NAB or any other place, there is no need for pre-registration. You can walk up, sign up, and take the exam right there. And they did this 2 years ago at the AES in New York, and they're doing it again. And I think it's great because so many people realize they want to take the exam at the convention, but they say, hey, I got to pre-register, and they forget and so forth. This time, you're able to get the instant satisfaction of going and taking a test, I guess.
That sure is convenient. Yeah, that's always been my problem in taking a test. I forgot to, I had to register like 6 weeks before or such. So that's really cool. You can register right there on site. David, if folks want information on this AES, it's aes.org, and then click on what?
You can just go to the 131st convention. And there's going to be more information coming up daily. And you can also go on to the Facebook page. I believe it's AES.org or AES.org, and you will see that as well. And the one last thing I want to mention is these are not just the only sessions at the convention. There's workshops, there's papers, there's sessions on live sound, there's master classes, there's workshops, everything, and there's keynotes. As a matter of fact, one of the keynotes of the convention, I don't know which day yet, is going to be our friend Skip Peasy. So going to the AES show, you'll find that it's more a show to learn, and it should be a destination for anyone that wants to be aware of technology.
Well, very cool. I've got to go to the last AES in San Francisco last fall and was very pleased to be able to give a paper there. And I had a blast. I got to meet some of the great luminaries in the business. Of course, people that we've known like Frank Foti and Bob Orban, Greg Oganowski, who's been on this show. And got to learn a bit too. I got to sit in on a few sessions, and you get to hear these folks talk about the future, where broadcasting is going and where broadcast audio is going, as we're talking about on this show, and processing and metadata. streaming. You get to hear about the future, things that they're thinking about that may not be products just yet, or maybe techniques for doing things better. So, David, I appreciate you being here and telling us about what's coming up at AES in New York. I'm sorry, go ahead.
One of the greatest things at that show was, if you looked out in the audience on almost all of the broadcast sessions, there was one row that had Frank Foti sitting next to Marty Sachs, sitting next to Steve Church, sitting next to Greg Oganowski, sitting next to Bob Orban. All five of them sitting there together. And afterwards, they came up to me and said, "These are really great sessions." I mean, that just blew me away. Here they are. Here are my radio idols saying that to me.
Very good. David, thanks for being with us, and we'll want to talk to you again probably just before or just after the AES, and I'm looking forward to seeing you in New York City in October.
Yes, and I'm looking forward to booking you on some sessions, Kirk.
Okay. Well, I got to clear it with everybody, including the missus, so hope to be there. AES.org, and then click on the 131st Convention in New York City. David, thank you so much for being with us. I appreciate it very much.
Thank you for having me. I hope I didn't talk too much.
Oh, you're good. You're good. And all that information is available on the website at aes.org. We're going to take just a moment now and hear a word from our sponsor, which is Axia Audio. And I'm going to flip my browser over here to the Axia Audio website on the web at Axia. That's AXIA, AxiaAudio.com. And I want to tell you about a console that Axia is just now shipped, the first few of these consoles this week. And that is the Axia Radius console. This is an audio over IP console. It does live wire audio over IP, just like its larger cousin, the Element console, or the original Smart Surface console, which Tom Ray has about 9 of those at WOR in New York, or like its slightly bigger brother, the IQ console, which was shown at the NAB this year and also last year as well. The Axia Radius console is, it's on a budget. You know, if you want to save some money and still be able to have an IP audio console with a lot of features, well, you ought to look at the Radius console. It has a list price of about $6,000, $59.90 actually. And the Radius console has 2 parts. There's the Surface that goes on the desk. And by the way, if you want to follow along at home, you can at axiaaudio.com/radius. So there's the Surface part, which has 8 faders plus volume for headphones and the studio and the control room monitors, also volume for studio monitors, and the ability to choose different presets. Now, since this console, it's got a physical part, right? It sits on top of the desk. You can assign the program buses, program bus 1, 2, 3, or 4. Program bus 4 also doubles as what we call the telephone bus. You can also, right on each channel, you can select the gain of each channel. There's an options knob at the top of each fader channel. So you can push that and select the gain. You can select other inputs, other sources right there on the fly. So if right now you say you have a source coming from a satellite receiver, but it needs to come from a different satellite receiver, or from a codec like a Zephyr or a Comrex or some other device bringing some audio in from the outside, you can just select it right then, right there, very easily on this console. It has very long life, long throw faders. And by the way, these faders, people ask us about these faders and what kind are they. I'll tell you, they're not waterproof, but they're water resistant. You can actually accidentally pour something into the console. There's no electronics under the opening where the fader slides up and down. And the way that the fader is built, the stem that goes into the knob and goes down in the fader, that stem doesn't go directly down in the fader. It actually goes around the side of the fader. So it looks like a normal fader from the top, but it's designed differently on the inside. And we chose that fader exactly for this, so that water won't go in, or if you spill a little bit of coffee, and more importantly, dander, just dust and things like that, and hair, and the things that usually get down into crevices. That doesn't get down into this fader. So that's very cool. Long life switches that we've tested for 100,000 operations. Hey, our research and development crew actually built a mechanical finger to push this button over and over and over again to make sure it's reliable. So that's the desktop surface. There's another part of the console, and that is the what we call the Core 16. The Core 32 is for our bigger IQ console. The Core 16 fits in your equipment rack, right, nearby the console, and it has all the audio inputs and outputs, mic level, line level, ins and outs, and it also has AES in and out. Plus, there's another very interesting thing on the back of this. There's an Ethernet switch that's built into the Core 16, as well as the larger Core 32. And this Ethernet switch is fully compatible with all other Axia devices. You just plug them in, and they work. So if you want to add an audio node, or add a phone system, or add a telephone that's powered over Ethernet, you can plug that right into the back of the Core 16 part of the Radius console. Check it out on the website, axiaaudio.com/radius. This is a very, very, very cool console. I've gotten to install a couple of these at trade shows, and I'm looking forward to installing one of them at my radio stations, hopefully later this year. On the web, axiaaudio.com/radius. All right, let's see. I need to find out if we have another guest with us yet or not. Can anybody let me know? Jeff Burke? Ah, there he is. Hey, it's Michael Catfish Dosh, and this is a bit weird. I got to tell you, having the not only the CEO of Telos on, but also my boss on the show. So I better straighten up and fly right. Hi, Mike.
You're doing a great job, Kirk.
Well, and you're doing a great job being my boss. I appreciate that.
Well, thank you. That's very kind. Well, but by the way, that lab you're sitting in right now, what console is that behind you?
Well, here, if they take my shot here, you can see I'm actually here. I am at Mike Dosh's house in his lab, and look, there's audio consoles here. There be console. In fact, here I got one over here. Gee, this is just a potpourri of audio consoles. Here's one.
Imagine that.
This one's so new, the plastic is still on it.
Imagine you'd find a bunch of consoles in my lab. That's a mighty strange thing to find there.
So, Mike, I wonder if we've already done the commercial for Axia. So I wonder if we could take a few minutes and be non-commercial, but still be technical. Most of the viewers of this show are broadcast engineers and those who are interested in broadcast engineering. And we've talked on a few shows about this notion of IP audio. In fact, Steve Church has been on the show. Why don't you kind of take us through how this whole idea of putting low latency, perfect quality audio over a computer network, how did this come about, and how do we get to where we are today with this becoming such a standard with thousands, literally thousands of broadcasters and broadcast studios having this technology in them?
Well, I guess I could take you probably pretty far back, all the way back into the analog days, because I think that's probably where we've had the idea in the first place. I used to work for a company called PRNE. They built quite a lot of pretty high-end broadcast consoles for major market stations around the world. They made BMX and radio mixers and products like this. And at one point, we had done a partnership product with SAS, the switcher company. And if I recall correctly, this might have been for KPIX. And KPIX had this idea that what they were going to do was they were going to use an SAS switcher to switch all of their sources, and then they were going to connect that to PRNE consoles that were going to become more like control surfaces and controllers for this routing switcher. And so we actually did that in the analog days. And then I would say that Klotz Digital, back in the 90s, they were the first people to do this in the digital era. They actually kind of had the same idea. They had a router core and console engine cores, and then they would basically use a centralized audio system where this engine would do all the switching and all the mixing, all the routing, and then they'd have these control surfaces connect out in studios. And these control surfaces, they would be more or less, I don't want to call them dumb, but they literally were just controllers, and all of the audio was centralized. And this gave you the benefit of being able to, for example, push a button and completely reconfigure a studio. Or to move a show from one studio to another pretty easily, instantly. And so that was kind of an interesting idea. And a number of broadcasters in the 90s jumped on this idea. About that time, I was looking at that thinking that's a really interesting idea, because if you think about it, a broadcast mixer is really not so much a mixing console, but it's really kind of a switcher that does a little bit of mixing. Most radio boards have 1 or 2 or 3, maybe 4 faders open at any given time. But for the most part, it's 1. And then there's a little segue, and then there's another one. And so this is not so much a mixing console as it is a switcher that mixes. And so this idea that the switcher is really the core of the radio facility is not such a far-fetched notion. And I do recall when that happened, and when CLOTS was coming online, we were also seeing quite a movement from traditional discrete sources like CDs and CART machines. You probably remember CART machines, reel-to-reel tape machines, and LPs, and all the other source equipment that people would use in a broadcast studio. We were seeing this all transition into the computer, and the computer was taking over as really the central audio device. So this was 80s, 90s, particularly the early 90s, and I remember looking at the computer and saying, it would be great if, in addition to having the router and the audio mixer in that console engine, if you will, that centralized thing, wouldn't it be great to also have the computer in that central core, or at least the ability to play audio in and out of that central core without having to translate it via sound cards or go into AES inputs and outputs and all of this sort of thing. It just seemed to me that you should be able to connect a FireWire connection from your computer source and have it get right into your router core, and then you would be able to take that audio and do whatever you wanted with it. And I remember having this conversation in the late 90s with Steve Church, and Steve said, that's a really good idea, but maybe not FireWire, maybe Ethernet. What if this was all on a network? And so that was kind of the evolution of consoles as they moved out of being a discrete device, and then more of a I guess you'd call consolidated device. And then ultimately, I think Axia was really the first company to introduce the computer as the third element of the very of what I believe is the very important 3 in the broadcast studio, and that's the routing, the mixing, and the audio delivery from the computer. You take those 3 and you put them together, and you've got pretty much 90% of what you need to do in a broadcast studio.
Sure. Okay.
So I would say that the idea, we had that for a while, but the technology, this was Steve's kind of breakthrough. He was thinking about what I was saying. I'm yakking about FireWire, and he's thinking about VoIP and what Cisco's doing with phone systems, and imagining that that's a much cleaner solution. And I have to say, in retrospect, that just opened the world. When we blended these 2 ideas, when we said, we're going to build our consoles on an Ethernet backbone, when we're going to build an IP infrastructure where we can connect everything in the broadcast facility together using packets, audio over standard Ethernet, we pretty much changed the way people are building broadcast studios, and that's really where Axia comes from.
So there's a part of this history that I'm stand a little confused on, and that is, you said that Steve Church looked at how Cisco was handling voice over IP across a network, and somebody imagined, well, couldn't we put broadcast audio across there? But I see a world of difference in the technical requirements of voice over IP, which is a relatively low data rate, although it does need to be low latency so you can have a true two-way conversation. But broadcast audio has got to be absolutely full fidelity and just as zero latency as you can possibly get, because not only are you talking maybe back and forth with somebody else, but in the broadcast studio, you're hearing your own voice through headphones, the mic through whatever system you're doing, and then into the headphones. And just a bit of latency can start to be a problem for what the talent is hearing in their own headphones. What made somebody believe that this problem could be overcome?
Well, actually, I think you You sound like you're playing the part of Mike Dosh in the conversation with Steve Church when he said, "Hey, you know, we could do this with Ethernet." And I think I remember saying that's just a crazy idea, because all I could imagine was dropped packets and latency and collisions on the network. And I thought, oh, come on, this will never work. And I said the same thing. I said, you know, come on, it's a phone, great. You know, it's super that they're able to have phone calls on Ethernet, but you know, this is broadcast audio we're talking about, so it can't be compressed. That was something that we had talked about early on, and we're not going to compress the audio down just so that we can get it across a network. It's got to be linear, and so it's going to be huge. These packets are going to be monstrous, and there's going to be so much traffic on a network. No, I just couldn't imagine this, and yet. It turns out that the technology, the underlying technology that enables VoIP to happen, is actually perfectly useful for broadcast audio. It's highly reliable. The switches that they built to do this VoIP function, they're non-blocking, which means essentially that every port can be fully utilized on a switch. And so we were when we build a live-wire network, we fully utilize those ports. We push those switches pretty hard.
That's an objection that in showing folks an early live wire setup of routing and mixing, that's an objection that often came up because so many of my engineering colleagues and friends and associates that I've met over the years had built their first Ethernet networks back in the days of hubs instead of switches that were pretty smart, managed switches. And so, hey, I remember working back at Scott Studios, back before Wide Orbit was DMARC, and before that it was Scott Studios. And we had a network there in the building, and every time we'd add another computer to it, the collision light would light up more often. And things got slower and slower the more computers that we added. So, in fact, I was showing an Axia system, an early one, in, of all places, New York City. And one of the engineers at the end of the presentation, and the thing obviously worked, raised his hand and he said, "That won't work. You're going to have too many collisions on that network, and it absolutely will not work." So had I not worked for Telos, I would have thought exactly the same thing, because my brain would have been stuck back in the time of hubs and not smart switches. So that's the kind of tech you're talking about?
That's exactly it. There are no collision lights on switches, and the reason for that is because there are no collisions. They can't happen. And then of course what we've done is we've written protocols, basically the way the audio is handled over the network, that pretty much take advantage of that underlying technology in the switch as I said, you're not going to get collisions, but there are even other things that we can do by writing our protocol the right way to make sure that audio packets take priority over any other kind of traffic that might be on the switch. That we're really taking advantage of the switch infrastructure. For example, in an Axia system, the way we distribute audio is we use multicast, and multicast allows us to send in one audio signal, if you will, and then the switch can send it to basically any destination. So you're very efficient in terms of your utilization of the bandwidth that you have there. So these are some of the underlying tricks, or I should say technologies, that we use to really exploit what the Ethernet switch can do. But I think what most broadcasters want to know is, well, okay, but does it work, and is it reliable, and is it going to be reliable as, say, an analog console or a digital standalone console? And the answer to that is it's brilliantly reliable. And you're able to use these off-the-shelf standalone switches that are actually quite inexpensive. I mean, I remember in those days when a mixing router engine core from a major console company using TDM technology might be a $50,000 thing. And you can buy an Ethernet switch that has just as much power that might be $3,000 or $5,000. So for 10% of the price, you have something that actually has more power.
Yeah.
And so we're able to move our customers in a direction where they're able to save money and actually do quite a bit more. And we haven't even touched on some of the other benefits, such as the ability to connect a computer directly into your to your network, just using a standard Ethernet interface that's already on your computer.
Hello. Hey, Mike, I tell you what, we're having a little problem with your video, so I'm going to carry on a conversation with Mr. Tobin for a couple of minutes, and I think they're going to call you back and bring you back in just a minute, okay?
Very good.
All right. Hey, Chris Tobin, you're still with us, aren't you?
I sure am. I'm listening.
Now, Chris, you've been a user of audio over IP technology, and certainly we've talked about bringing audio in from outside the station numerous times on this show, and I think on this show we may have talked a bit about your experiences with in-studio audio over IP, and you had, for a time, you had an AXIA system there in New York City. So tell me what your misgivings were at first when you heard about doing this live audio over IP in a studio, or maybe you didn't have any misgivings. Tell me what your reaction was when you heard about this tech and thinking about, could this actually work?
Well, when I first witnessed the use of the technology at Tom's radio station at WOR with the introduction of live wire and AXIA there, and noticed the way the architecture is set up, I didn't have any misgivings. I realized it could definitely do what it said and more. And then when I was talking with one of the technical reps with AXIA at the time, I forget who it might have been, and I started inquiring about taking advantage of Ethernet and the protocols of the LANs and everything I could do. And when they said, yeah, you can do that, just understand the overhead's a little greater and packet size is larger and you just have to deal with it a little differently. But yes, you can definitely go in the direction you're thinking of. So I was definitely impressed and said, wow, okay, this is going to be interesting to see how it goes. And you're right. A lot of folks in the group that I was with looked at this and said, there's no way it's reliable. IP technology is immature. It has issues. This is ridiculous. And you can't have critical audio in this form. I don't know. After looking at the way it was laid out and the way it's designed, I said, well, you can go one of two ways. You could plug in cheap hubs and really make a mess of things, buy cheap switches and make even more of a mess, or sit down and smartly design a system based on the protocols available and come up with something very robust. And years later, I had the opportunity to do that at our facility. And yes, we did install an AXIA system. We had it for a couple of years in a full-blown 24 hours, 7 days a week newsroom. And I have to say, it performed as advertised. And I know some of your technical staff, we did give them a little bit of a challenge. And as Catfish pointed out, the AXIA system does stress switches in the way it works, but it does function. And I came up with some creative ways to design the system so that it was robust enough to be considered almost, I could confidently say, we had 4 nines of reliability on the AXIA system. And,
here's something that's a little bit interesting, I think, in that on a recent episode on this network, on the TWiRT network, on a recent episode of Security Now, Steve Gibson has been taking us again through how the Internet was invented and how the Internet works. And it's a great series. He did this before, and he's got some new information and better explanations now, and I'm really enjoying it. And one of the interesting things about audio over IP in a closed environment versus audio over IP in the Internet, these are very different things. And maybe a few years ago, these weren't so different, because on a LAN, on a local area network, before we had switches that were managed switches that were non-blocking switches, we could drop packets, and you know what? Ethernet IP, TCP IP, was designed to accommodate that. And the Internet, the public Internet, is designed to accommodate dropped packets. I think we probably dropped fewer than before, but we're also sending a whole lot more than before over the public Internet. So when folks asked me or asked someone about audio over IP technology, hey, don't you drop packets? Doesn't that cause dropouts? The answer is no. There are no dropped packets because we're not using the public Internet as a transmission medium for live audio over IP, such as LiveWire and the other competitors out there to LiveWire. We're in a closed environment, and everything works exactly as it was designed to. Non-blocking switches, quality of service is honored. And there's just no opportunity for packets to go away and be dropped. And we're not using TCP IP either. We're using UDP, so the packets are not going to be sent again. They better get through the first time, and they do. Hey, I think Mike Dosh is back online with us now. Mike, are you there?
He's not back yet.
Oh, he's not back yet. Sorry. Thought he was. Okay.
Yeah.
So,
well, you're absolutely right. The closed system, there's a benefit to it, and you're not dropping packets, and you control all factors of production of the packet to and from, and start to finish. So if you do it smartly, you can create a very, very robust system, as Catfish pointed out. And I tell you, the system when I used it, the Axia system, was quite flexible. Did a lot of things that I don't think you can do with many other systems that are on the market at the moment. And in a news environment that I was exposed to, we didn't have time to sit and dilly-dally and figure out what to do with flipping switches, pulling cables, moving connectors on the backplane of some device. It did it all in software, and with Pathfinder, which you can do even more with. It really, as I think I told Mark Johnson, right? Yeah, Mark Johnson, one of the techs, now I think runs the tech department. I told him, I said, you're basically limited by your imagination. That's what it comes down to.
So we're back with Mike Dosh, and Mike, you want to try to pick up where we left off and then kind of bring us more into today. I think we were talking about getting all these things working together, and they are. The whole notion of wrapping your brain around your radio station now being on a network instead of all the usual cables wired from one Gazauta to another Gazinta. It's really strange for a broadcast engineer to think about distributing audio this way over a network. How did you work through that, and how do you see other engineers working through that transition of mindset?
Well, I guess the first time that I actually hooked up a console, put together a smart surface using this new LiveWire tech. This was in a lab pretty early on. I guess it was about 2002, 2003, while we were still developing this. I fell in love with it pretty quickly. This idea of connecting up pretty much everything with a handful of Ethernet cables and not soldering XLR connectors and stringing cables back and forth between studios. It's pretty nice, especially if you spend any time in a rack room punching down cables into terminal blocks and all of the other stuff that broadcasters have done through the years, and dealt with cable bundles as big around as your head. Having all of this become just a single Cat5 cable that literally is carrying hundreds potentially of your audio signals. I think once people see what they're able to do with this, I think they get attached to it pretty quickly.
I was just thinking, I spent most of the Reagan, Bush 1, and Clinton administrations up in attics pulling multiple cables through places and getting really good at punching down on 66 blocks and Crone blocks. And I don't ever want to do that again. There's
Indeed.
Nothing about that interests me in the least. I wish this technology had been around during most of the time when I was building dozens of radio stations across Middle America. But I'm glad it's here now.
Indeed, you mentioned something a little while ago, Kirk, that I thought was pretty interesting, and it's a source of. I'd say that even today, as much education as we've done, and as much success as we've had, it continues to be a source of some confusion amongst broadcasters, and that's this idea of IP audio, and it applies to the way people are moving audio over public networks, for example, or wide area networks, versus moving audio over a local area network. And these are very different, and yet we apply the same term to both of them. We call them audio over IP, or we call them IP audio. And as we confuse the two, we do ourselves a great disservice, because they are just so completely different. For example, Telos, our codec company, manufactures codecs, historically has built a lot of codecs for ISDN and other telephone network connections, and we also now have a family of IP codecs. And these IP codecs are built to move or to connect a couple of disparate locations together using either a telco connection, such as a T1 or a T3, something that an MPLS circuit that has quality of service, or even if the customer wishes to connect a couple of locations together with a public internet. And of course, if you're going to send audio streams over the public internet, you're going to have some challenges. And so these products are designed to compress the audio, to make the streams as small as possible. They're designed to navigate through various kinds of connection roadblocks, if you will, firewalls, and punching through various ports that you might have open on various routers, and then dealing with varying network conditions. So as in the middle of your broadcast, where you're actually using this public internet, and the network deteriorates. And a little while ago, we just had my camera go away because we're using Skype, and there was some issue involved there. And in fact, I think we were in the middle of talking about how reliable IP audio is, and that's about the time that I went away for some reason. And yet, what we're talking about here is a public internet connection that. Well, quite frankly, it may or may not be all that reliable over the course of a minute or 2 minutes or an hour or 2 days. And so we make products that do the best they can over these kind of unpredictable conditions. And we call that IP audio. And everybody in the industry calls that IP audio. And then there's the stuff that we make that's on the studio side. And on the studio side, we're on the local area network. And we own that bandwidth. We understand it. The reliability over that network is phenomenal. The error rate is virtually immeasurable. We have complete control, and we're able to take audio and connect devices together with huge packet rates. Basically, we do not compress audio. We actually send it across linear, 24-bit linear audio, and just hammer these networks with packets, and every single one of them gets to its destination, and it gets to its destination with predictable latency that's in the microseconds. How do we do that? Well, it's a local area network, and that's a whole different animal than a public internet connection, and but we call them both IP audio. And I wish we didn't, but that's the industry, and that is a source of some confusion for people.
I've often thought we should come up with a different term for that. In fact, I think Steve Church and Skip Peasy, both of whom have been guests on the show, have a book that they wrote together about IP audio, and these terms are used somewhat interchangeably there as well, IP audio and AoIP, or audio over IP. Mm. So some folks in the chat room, Mike, are asking about the standards that Livewire uses, and they're also asking that in the direction of, well, what about making this a standard that others can use, an RFC or some such as that? I'm not well versed in these kind of things, but can you help us understand about audio over IP and standards and Livewire that's very low latency?
You bet. That's a terrific question. In fact, when we started this program, we assumed that we made a bad assumption. We assumed there would be some protocol off the shelf that we'd be able to use. We never set out to invent a protocol, we imagined that we would use RTP, for example, or that we would even use an existing protocol like CobraNet. At the time, this was a way of moving audio over an Ethernet, and we realized as we started to dig into things that there wasn't anything that quite delivered what we needed in terms of reliability, low latency latency so we ended up inventing our own protocol, which sounds like a big deal. Sounds like we went off and actually, from the ground up wrote something. In reality, what we did was we took a group of standards that existed already, one of them being RTP. Another, in fact, if there is anything proprietary in Livewire, it's really the way we distribute a clock, so that devices can synchronize. And there just wasn't anything at the time that you could use for a clock reference in an audio network like that. We're a little bit later now. We're actually 7-8 years after we invented this protocol, and the world has changed a little bit. The IEEE has gotten behind some new technology that potentially is going to be built into switches in the future that allows for precision clocks to actually be part of your network, and of course Livewire will use those clocks. So one of the things, and this is one of those areas where the competition has perhaps explained LiveWire for us, to their benefit, and they've kind of scared some customers and said, that's really a proprietary thing. It's not an open tech. You really should stay away from that. The reality is it's very open. It's very available. It's published. We in fact offer a free license. Well, I shouldn't say a free license. I guess there is a nominal charge to become a licensee. I think you have to pay $500, and then you can make 1 million products if you wish that have LiveWire. So it's not exactly a huge moneymaker for us, but basically it's very open, and we've shared this with a number of companies. It's not terribly difficult to implement if you know what you're doing. At this point, I think we have about 34 partner companies that are all LiveWire compatible, which means that not only will these companies all be able to connect to an Axia network, but they'll be able to connect to each other. So this idea of having an open standard that the entire industry can use, ours is pretty open, and it's available to anybody who wishes to use it and put it into their products without any exceptions.
What's the future hold for the Axia product line? If I can jump in and ask that.
Hey, Chris.
Hey, Mike.
Well, we're going to keep building consoles because we enjoy that very much. We've got some new products that are recently we introduced an intercom product. In fact, when I was out talking to you a few years back, this was something you had expressed an interest in, and so we've since launched a LiveWire-based intercom product that has been popular amongst some of the larger broadcasters, and some TV stations have shown some interest in it. We will continue to further the cause in terms of IP audio. We really believe in it, so we continue to work hard with partner companies to find ways to help them bring their products online. And along those lines, we just shipped our very first card this week. We now have a card that you can implement into an audio product that basically takes the place of a Dolby E card, and instead of Dolby E over an AES-3 connection, it uses the same audio I/O on the back end, but it's LiveWire instead of AES-3, and so. This is a way for people that they've already got slots basically for Dolby E. They can implement LiveWire right away. And so some people are looking at this as a way to retrofit existing products. Some people are looking at it as an inexpensive way or a very fast way to bring on a new product. And in addition to that, we're also opening this up to our partners. Basically, that license that I was talking about earlier gives you full access to all of our intellectual property. So we not only are we selling that card, but our real interest in it was to design it as a reference design that others can copy and use as the basis for building LiveWire right into their very own products. And that's a recent thing that just started shipping last week.
I think I've got one more question, Mike, and that is we've talked about this notion of this low latency AOIP and full quality being in a kind of a closed environment, that is a network that doesn't touch the internet or doesn't necessarily go out over a WAN. But I think we know of a product available from some telephone company providers called Metro Ethernet. And Metro Ethernet is being used in at least one city in Hong Kong to connect LiveWire Axia studios underneath is the Hong Kong Harbor, Victoria Harbor, I think is the name of it, between two different locations of a broadcaster there in Hong Kong. So my question is, would you think that as we move ahead, for example, Comcast in my neighborhood is going to start offering 100 megabit download speeds? Do you see a time when the internet or some portion of the internet is going to be able to, or maybe some private WAN type product is going to be able to handle this kind of low latency audio, and we can connect stations together?
I do believe the answer to that is yes, Kirk. And as you pointed out, there's some technology out there right now, MPLS, and I guess actually I think Metro Ethernet is a commercial name. You know, it's like a brand name for an MPLS circuit in Hong Kong. And the idea here is that as far as the user's concerned, it looks like an Ethernet cable with one end in one city and one end in the other city, and it behaves like an Ethernet cable. And this is one of the beautiful things about IP audio. You know, this is not a proprietary thing that requires a Telos or an Axia solution. These are packets, and these are packets formatted for distribution using the Internet Protocol over standard Ethernet circuits. And so it as long as you've got an Ethernet compatible interface, there's a very good chance that it'll work right out of the gate. And as time goes on, there will be more and more of those services available. One of the things that we talk about a lot is the difference between QoS and non-QoS. And QoS is essentially this idea that I'm going to have consistent quality on a particular link. And an example of QoS that we're all pretty familiar with is a T1 phone line. You know, T1 data phone line, for example. This is consistent performance. We know it may not be a high data rate, but we know that it's going to be a consistent data rate. And so there's no variability in terms of, well, it worked for 10 minutes and then it slowed down. So that would be considered a QoS circuit. And there are quite a number of those, and MPLS or Metro Ethernet is one of those. And then on the other side, we have non-QoS. And non-QoS is what we generally think of as those connections. It's that Wi-Fi connection at Starbucks. It's that Comcast cable modem connection that I've got in my house. These are non-QoS services, meaning that even though the cable company might tell me, your average download speed is 10 megabits per second, they can't guarantee that I'm going to get 10 megabits per second, or even 5 megabits per second, or even 500 kilobits per second every second for 24 hours a day. That's not what they guarantee. What they say is that your average download speed is going to be some, very impressive number, and we broadcasters need to think about that. We need to be careful not to get too excited about the stated bandwidth, and we need to think about the service quality. But I do believe the answer to your question is long term. Absolutely, there's going to be QoS services, and maybe even in our homes at some point we're going to have QoS services. Bandwidth is not getting scarcer; it's getting more common. It's getting cheaper all the time, and it's getting better all the time. So why wouldn't we be able to take advantage of that?
Gotcha. There's a lot of discussion on the chat room here and there about bandwidth caps, but I think those generally are wireless bandwidth caps, and we're not talking about wireless here for an audio over IP.
I will tell you one thing. If you were to take a live wire console and try to connect it to a network that had a bandwidth cap, you'd probably be able to use it for about 10 minutes. Yeah,
that's right. In fact, when I first found out how much bandwidth it takes for a stereo stream, there's a fair amount of overhead and QoS and packet headers in live wire and other similar low latency audio over IP solutions. In fact, I think part of this extra bandwidth is actually to speed things up, because live wire in its low latency stream uses very small packets, or they have a small payload. So the header stays the same size, the payload is smaller, but these smaller packets get through a network a lot quicker than a full-size packet does, one that's more efficient. And that was part of the key of making a low-latency AOIP system, wasn't it? Small packets?
Absolutely true. If you had a big packet, you can take it to the extreme example. If you had a big monster packet that actually had 2 or 3 or 5 seconds worth of audio in it, you'd have to process that entire packet. And so you'd have at least 2 or 3 or 5 seconds worth of time before you were able to actually, get audio at the back end. And so in order to get the delay down, we want to have a lot of very small packets that represent a small fraction of a second of audio. And or less than a second of audio. Generally, we have from input to output, and we like to express this in practical terms, because we've seen people that have said, well, we have lower latency than Axia. We've seen this kind of claim, and when you look carefully at what they're measuring, it might be the time that it takes for a packet to move from a switch to an engine, or from an engine to a node, or a terminal adapter of some type. And we don't find this a terribly useful measurement. It's kind of like saying, well, my car can go from the city to this city to another city in 20 minutes, but I'm only measuring these 2 points in between, and I'm not going to tell you about the time that it takes to do these other things. And so what we do is we use a practical measurement, and that is we say that from the time that you speak into a microphone till the time that you hear the audio coming out of the headphones, and everything in between, whether it be the switching time on the network, the time it takes to go through various internal connections and processes, and converter delays, A to D and D to A's, all of these things take time. In a live wire environment, that's less than 3 milliseconds, which is pretty low number. In fact, to put that in perspective, I think it's 2.7 milliseconds. That's kind of the equivalent of moving just a few feet away from your microphone. That's how much latency you're going to hear. And so generally we like to demonstrate this. We'll give somebody a set of headphones and put them in front of a microphone and say, okay, you tell us how much latency you can hear, and then the eyes get big because it's so low they really can't hear it.
Yeah, I remember the first time we have some engineer friends at Minnesota Public Radio, and they were checking out lots of different technologies, and audio over IP turned out to be one of them. And I think they had like a lot of folks, I'm not picking on them, they had a preconceived notion that they were going to put the headphones on, talk in a mic, and hear some kind of an echo or some slowness going on there, and they put they wanted to test it out. So we plugged it all up, and they tested it out, and they talked in the mic, and they said, oh, that'll be just fine. So no latency that was detected.
Yes.
And in the whole world of IP, latency is something that we're kind of so used to, whether it's sending an email or a text message or even watching video that's been buffered up for 30 seconds. We're kind of used to that. Hey, we got to go. I wish we could talk a lot longer about this technology. I'd like to have other engineers and other folks who can talk to us about AOIP, and we have, and we will continue to do that, because it's certainly a subject that is of interest to folks who are interested in broadcast audio and lots of consumer audio too, because this audio in packets is just everywhere and will continue to be for, I'm sure, the rest of my life. Mike Dosh, thank you very much for being with us. Appreciate you taking a little time this evening.
It's my pleasure, Kirk. Thank you.
And Chris Tobin, the best-dressed engineer from New York City, thank you for being with us. Appreciate it.
Oh, thank you, Kirk. Anytime.
All righty. And we'll thank David Bialik for being with us, too, and encourage you to check out his website or not his website, but the website he's talking about at AES.org for the AES convention coming up in New York City. And our sponsor, and also the company that Mike Dosh is with, and that is Axia Audio. Check them out at axiaaudio.com. Hey, we got to go. Thanks for joining us. We're going to have another great show next week on This Week in Radio Tech. Also, thanks to Burke and Jeff for switching the show back in Petaluma, California. We appreciate that very much. You guys take care. We'll see you next week on This Week in Radio Tech. Bye-bye.